Let us start. It probably takes 10 minutes. Okay. So in the 6.5, I hope by now you'd have completed your lab 6. So in lab 6, your work was to identify whether it was a normal distribution or not, right? So in 6.5, that is what we are going to learn. We will have a certain plots and we are supposed to identify whether it is normal or not. Okay, that's the only task you have now. Now, what is a normal quantile plot, or also called as normal probability plot? It's a graph of points where each x value is your original set from the sample data, and y value will be the z-score. So how does the QQ plot look like? QQ plot means quantile plot. Okay, you will have a straight line and you will have some dots, right? That is what you have seen in your lab 6. Let me show it to you. Nice distribution column, click on OK. You don't have to do this. This is lab 6 actually. So we have quantile plot here. Okay, looks good. Okay, so I hope students in WebEx, you are able to see this, right? Are you able to see this?
Yes.
Thank you. Okay, so here, this is called as QQ plot, the one with the line here, line and the dots, okay? So this line, the straight line, what you can see there is called as a reference line, okay? And the dots here, the black dots, are your data points of the variable height, okay? Now, how do you check whether it is normal or not? We want the data points to be as close to the straight line. Not only that, it has to form a straight line also. It has to form only the straight line. So sometimes you will have a graph like where it deviates like this. It looks like a straight line, but it deviates. So that is not called as normal. Okay. So how can you identify whether it is normal or not? You'll be seeing in the section 6.5. Now, before that, can anyone tell me what is this plot called as? Okay, so can anyone tell me what is this plot called as? The one in the middle, right above the histogram. Any idea? Exactly. It's a parallel box plot where you will have all the 5-number statistics. What are 5-number statistics? First quantile, second, third, mean, and median, right? So that is called as 5-number statistics, and this is your parallel box plot. Now, why do we need this and how does this help to check whether it is normal or not, to check the normality? Now, you can see the line above the box plot, right? The red line. So that is nothing but your red line in the QQ plot, the same reference line there. Now, if you are unable to do the QQ plot sometimes due to some reasons, then you can always check the parallel box plot and the reference line. Okay? If it is outside the box, then you can easily say it is not normal. If it is somewhat close to the box, then you can say it is roughly normal. Okay? Now, and one more way you can do this is by checking the histogram. You have to get a bell-shaped curve. Okay, now to get that, Okay, you have to get a bell-shaped curve like this. Sometimes you will be getting skewed left or right. Sometimes your bell will be onto the left or right. Okay, so that time the variable is not normal. In this case, it is a bell-shaped curve, so it is normal. Okay, now this is how you used to check in your JMP when you had the lab 6. Okay, so that's your normal quantile plot. Now, how can you identify the variable as normal or not? First thing is histogram. By looking at the histogram, if it is having a proper bell-shaped curve, then we can say it is normal. Or identifying the outliers. So the example which I showed you did not had the outliers. How can I tell that? So when you take a look at the parallel box plot, you will have some dot. Okay, you will have a dot at least to the left or to the end of the right. So that time those dots are the outliers. Okay, in presence of such outliers, we can easily conclude that the variable is not normal. That's the second way. Third way is by looking at normal quantile plot. I told you earlier in the example. The data points has to form a straight line and it has to be close to the reference line. Okay, so these are the three ways you can conclude the variable is normal or not. Okay, this we have seen. Okay, we will look at one example here. Now, the first case is showing the IQ scores, and that is histogram, as you all know. Now, if you can draw a bell here, bell-shaped curve, and check whether it is proper or not, you will easily conclude whether it is normal or not. Or you can take a look at this, and if you see here, we have a straight line, and the data points are very close to the reference line. Not only that, it is forming a straight line, right? It is not forming any other pattern except straight line. So we can easily conclude it is normally distributed. Okay, this is one example. Second example, uniform, where the frequencies will be always equal. Okay, this is your example for uniform histogram. Now, tell me whether it is normal or not. Data points are very close to the reference line. No. Why? It is having a deviation. Okay, this is where you will fall. So thinking that it is close to reference line, that doesn't make the variable normal. Okay, you must be having a straight line. Take a look at this. Now, before you take a look at the QQ plot, if you check the histogram, it is not at all having the bell-shaped curve, right? So here only you can conclude it is not normal. But let's also see the QQ plot. Here, if you can see, it is not close to the reference line, but it is close to the y-axis. So we cannot say it is normal. So these are a few examples where you can check the normality. Now, you had JMP while you were doing lab 6, so you were able to conclude whether it was normal or not. Now, during your test 2, you will not have that. So how do you do that? You can do that using your calculator TI-83 or 84 or Casino. Okay, so we will see how to do that. We have a video which is already uploaded in the Blackboard. So before I go to the calculator, very wrong ad.
normal quantile plots to determine if a data set is normally distributed. So that's something we're often very interested in. We have a data set and we want to say, oh, does this seem like a normal distribution would work well to find probabilities for or to somehow describe it? Okay, so what we have is we could just look at our histograms. You'll see here all of these blues are our actual histograms. Okay, so I could look at this one and say, oh, well, that looks like a normal distribution. That one would probably work. Okay.
You want me to slow it down? It's normal, right?
Or I might look at something like this one and say, oh, that does not look like the normal distribution. That one probably wouldn't work. But instead of just looking at the histogram, we invented something called a normal quantile plot. We use software to make a normal quantile plot to tell us if our data set is normally distributed. Okay. And the normal quantile plot, what it is it's comparing your data to an actual normal distribution. And so if your data is normally distributed and you compare it to a normal distribution, they should line up nicely and form a line. So if the points on the normal quantile plot lie close to a straight line, because again, it's comparing it to a normal distribution, so they line up in a straight line, we know that the data is approximately normally distributed. So I put these in two columns here. The first column is the data is approximately normally distributed. So you can see here, this one looks very normal, almost exact straight line. This one is kind of fairly mound-shaped, not exactly normal, but pretty close, and fairly straight line. Okay, fairly normal. These are all fairly straight lines, and the histograms look fairly normal. Okay, even these ones, again, look fairly normal. Notice this one is a little bit left skew here, and you'll kind of see my normal curve plot kind of dips a little bit. But overall, it's still a fairly straight line, and I would say this data is at least approximately normal. Now, in real life, you usually don't have data that looks exactly normal because data in real life is just messy. So if it's close to normal, we're pretty happy with that. Let's look at our second column. These are things where the data is definitely not normal. So this one doesn't look like a normal distribution at all. It looks fairly flat or fairly uniform. Everything looks about the same height. And notice the normal curve plot is not a straight line. It's definitely a curve, so not a straight line. This one that was left skew, notice it kind of scoops down. A straight line would be like this. It scoops down quite a bit. Here's another one that was more uniform, and that is definitely a curve, not a straight line. This one up here was right skew. I'm not sure what I said. This one down here is left skew. It has that long left tail. If I was to go like this, oh, yep, that was supposed to be a straight line. There's no way that's a straight line. Okay, this is another right skew one. Okay, definitely curved, not a straight line. This one, again, a straight line would be more like this. That's definitely not a straight line. So these are all data that's not normally distributed. Okay, the reason we care is because later on in almost all of our sections, we'll say, oh, if we want to do this test, our data needs to be normally distributed. This is a good way to check to see if your data is normally distributed.
This is you, or at least it could be you.
So that was example for normal quantile plots. Now, if you all can open your calculators, and I want you to follow the video here.
Learning about the normal distribution. And we've always just told you that some data set or some situation is a normal distribution. But how can you tell if you're just given a data set, if you could apply the rules that we learned about the normal distribution to that example? So this is section 6-7 in your book. Called assessing normality. So we want to decide if we have a data set, is it close enough to a normal distribution that we could use what we've learned? And none of this is going to be kind of as rigorous or scientific as you might want. But here we're just going to give kind of some simple things that you can do to see if it's good enough. Okay, and here it's not like linear correlation or something where we have a standard, but we're just going to kind of be looking at it and saying, yeah, that looks normal. Okay, so the first thing we're going to do is make a histogram. So you learned how to make histograms in Unit 2. We're going to use our calculators here. I'll show you how to do that. If it doesn't even look bell-shaped, you already know it's not normal. The second thing you can look at is any outliers. If there's more than one outlier, it's not going to be normal. Okay, so in some ways it's very easy to determine if things aren't normal. If it doesn't have a nice histogram that's bell-shaped, that has too many outliers. Now, if it does have a pretty good, nice bell-shaped histogram, you can use what's called this normal quantile plot. And what that is, that plots every value in your data set is the x-coordinate. You're going to make kind of like a scatter plot here. And the y-coordinate is its z-score. So remember, we learned how to find the z-score. The x value minus the mean over the standard deviation. And the great news is your calculator will do this for you. If that turns out to be a nice straight line with no other patterns, then you can say that it's pretty close to a normal distribution. Okay, so we're going to do 2 examples here with some data set that you've already seen from Unit 1. Okay, so you'll see I actually have Unit 1 lab pulled up here. And so this first one, we're going to look at the ages of the people who are on the Queen Mary on westbound crossings. Okay, so I've already put that into our L1. Okay, I already entered those just so it wouldn't waste your time. And what we're going to do is we're going to first hit your y equals, and we want to go up and turn this plot 1 on. So just go up to it and hit enter. So when you move away from it, it's blackened. Now to make a histogram, you're going to hit second y equals, go to where it says stat plot, hit enter here, and you'll see histogram is like this third one. So hit enter, choose the histogram. Okay, make sure this says L1. And then, now, if you just hit graph, you're probably not going to see anything. I do really like this calculator because if you hit zoom and go down to 9, zoom stat, it will pick the right one for you. Now, you can already see that this does not look like a bell-shaped histogram. You could already say, no, these do not come from a normal distribution. Let me show you how you can see the normal quantile plot that we're going to talk about and see that it doesn't fit a straight line. So we're going to go back to stat plot, and this very last one, this is really cool. It's going to automatically make this normal quantile plot for you. And so we're going to leave this L1. You're going to leave X here. This is just what you want the dots to look like. And again, we're going to choose zoom, and you can just hit 9 or hit zoom stat, and it'll make it for us. And you'll notice, even though it does look kind of like a straight line, it kind of has these dips or these patterns, and you don't want any patterns. You want it to really look like a straight line. Okay, let's do one more example. We're going to look at the heights, and we're going to put in these boys' heights that we saw. You know what, let's go ahead, just because they're a little bit easier numbers, let's check out the mother's heights. Okay, so I'm going to put these in. Heights are something that we normally consider to be normally distributed, so let's see if this data set shows that. Okay, so we've got those 20 values in there. Now let's go back to the stat plot and choose our histogram to take a look at it for a minute. Okay, whenever you change these, you're going to want to do zoom 9 to zoom stat. And you'll notice this isn't perfect bell shape, but it's definitely a lot closer than what we saw before. And we could kind of see how it could overall be a bell shape. So let's go ahead and look at that normal quantile plot. Again, zoom 9. okay? And these still aren't perfect, but you'll see there aren't any little clusters like we saw before. They fall much more into a straight line, okay? So, you know, if you can answer yes, it's like a bell-shaped distribution, yes, the normal quantile plot is a straight line, that's how we tell if something's normal or not.
So that was about your 6.5, accessing normality. Okay, now I want you to go home and then check this video again, watch it, because you have this question in your test too, and I want you to do good in that. Okay, you have to know whether it is normal or not. So let us start test 2 review. Now there is already a practice test uploaded in your Blackboard. You just have to go to your section, and under test you have practice test here. So we have exam 2, sample practice test. Now it is not mandatory for you all to do it. It is just a practice. Okay, click on that, start.